Howdy ho, pre-calc friends. Mrs. Hershey here to share with you Note 6 on graphing rational functions. All right, so let's start with what's a rational function? What's a rational number? Let's start even with that. What's a rational number? The definition of a rational number is any number that can be written as a fraction. So a rational function is just a quotient of two polynomials. So here's an example of a rational function, okay? And here's an example of what this rational function looks like graphically. All right. So maybe you can take a look at this and see some things that are unique about it. Like you see there's a break in the function here and a break in the function there. Do you know what we call those? Well, there's lines there that we draw in to represent that break. And we have one here, and it looks like we have one here. Do you know what those are called? You said it, asymptotes. Remember that word from Algebra 2? Not a swear word, but if your mom's a math teacher, she may say like, hey, get your asymptote over here. I know, you guys are laughing. Math humor is just the best humor. So we have some vertical asymptotes here. It looks like at x equals 2 and x equals -2. Now, asymptotes are lines, so you have to write them as an equation of a line. And we have vertical asymptotes and something you might not be as familiar with, horizontal asymptotes. We also have oblique asymptotes. We're not even go near that. But we're going to talk about asymptotes today and some other features of a graph, of a rational function graph. So we're going to take it from given this rational function to graphing it, making sure we algebraically find our vertical asymptotes, our horizontal asymptotes, our x-intercepts, and our y-intercepts. So that's the task for today. Okay, let's just clearly define what an asymptote is before moving forward. So an asymptote here is a line that a curve approaches as it heads towards infinity. What I've illustrated here is a vertical asymptote, and so the guy's saying you shall not pass. Now that is true for vertical asymptotes. The function approaches, never touches. And so back in the day, I used to sing a little MC Hammer, Can't Touch This. Certainly dating myself here, but that song always runs through my mind when I'm graphing for vertical asymptotes. But this is only true for vertical asymptotes. Our rational functions can cross our horizontal asymptotes. Can cross. Not always, doesn't have to. And I'll show you how to figure that out algebraically as well. All right, so let's break this down piece by piece. We're going to find our vertical asymptotes algebraically, our horizontal asymptotes, our x-intercepts, and our y-intercepts, all algebraically. Okay, and our calculator will certainly be our best friend through all this as well. Okay, so vertical asymptote. We have vertical asymptotes at all roots of the denominator. So the way we determine the roots of the denominator, we set the denominator equal to 0. You're probably used to that when you're asked to find the undefined values. So when you set the denominator equal to 0, we are looking for those undefined values. Well, now that makes sense that a vertical asymptote would be there because the graph, the function approaches it, never touches it, meaning it's not included, okay? So how do you write your vertical asymptote? You write it as an equation. It's an x equals, it's a vertical line, so it's an x equals equation. And we usually graph these using dotted lines because they're not part of the graph, okay? Now here, that was my illustration that the function cannot cross a vertical asymptote. Can't touch this. No, do, 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 do. No. Luckily, we're not in person because I would certainly be breaking out my MC Hammer dance, maybe wearing my MC Hammer pants too. All righty, so let's go back to our example and find our vertical asymptotes, which we already figured out graphically, but we want to do it algebraically too. Okay, so here's our denominator. All right, for our vertical asymptotes, VA, we abbreviate it. We set our denominator equal to 0. So I'll write that down denominator equal to 0, and we solve. So I'm going to factor this, and then I'm going to set each factor equal to 0. I know I'm dragging this out. And x equals -2, x equals +2. So those are our vertical asymptotes. Right here, x equals -2, x equals +2. Okay? All righty. Let me erase this here, because I'm going to use the space to do the rest. All right, let's go on to a horizontal asymptote. Lunch is in my throat still. All right, let's highlight this, pull it from the page as it kind of gets blended in and doesn't stand out. So a horizontal asymptote crosses the y-axis. So it is also an equation, and we write an equation of a horizontal line as y equals. So y equals is how we write our equation. All right, so now what we need to do, thank you, Wesley, is talk about how we determine our horizontal asymptote. There's 3 ways. 1, 2, 3. Okay, 3 ways. So to determine it. So n and d, what are n and d here? N is the degree of our numerator, numerator, okay? So, and d is the degree of our denominator. So if we go back to that example here that we've been working with, we see our degree for our numerator is 1, and our degree for our denominator is 2. So in our example, we have n equals 1 and d equals 2. Now, in case 1, if n is less than d, HA is our horizontal asymptote. Our horizontal asymptote would be y equals 0. If n equals d, which it's not, we create our equation by taking the leading coefficient of our numerator and dividing it by the leading coefficient of our denominator, and that will give us the equation of our horizontal asymptote. And then the last case is if n is greater than d, no horizontal asymptote. Okay, so in this case, n is greater than d, so 1 is greater than 2. So that means my horizontal asymptote is y equals 0. All right, let's see here. Go back here. Y equals 0 is right here. And notice the function does cross the horizontal asymptote, and that's okay. It's not okay for vertical asymptotes. So that's y equals 0. Okay, that's our horizontal asymptote. I'll write that down here, how we determine that. We take the degree of the numerator, n, 1, and the degree of our denominator, which is 2. And if 1 is less than 2, or n is less than d, we have a y equals 0 horizontal asymptote. Okay? All right. Let's keep going to the next 2 parts, x-intercepts and y-intercepts. Oh, I forgot this part. The graph can cross a horizontal asymptote, so I certainly want to pull that from the notes and highlight that. And the way you want to see if a graph can cross is you take the simplified equation and you set it equal to the horizontal asymptote and you solve. Maybe I should illustrate that now. I know we will illustrate it in the examples, but let's go ahead. So simplified equation equal to our horizontal asymptote. Okay. And that will help you determine where it crosses. So let's put that here as a question. Cross, well, let's figure it out algebraically. We set the equation equal to the horizontal asymptote and solve. So our simplified equation here is x plus 1 over x squared minus 4. You can't simplify it any further. Let's set that equal to 0. Okay, we can put this as 0 over 1 and solve. Okay, so let's cross multiply. Here, we get x plus 1 equals, here, we get 0. Subtract a 1, x equals -1. All right, so there is a horizontal asymptote the horizontal asymptote does cross the function at -1, 0. Let's see that. -1, 0. Looky, there it is. That's where it crosses. Yes, we could have looked at that graphically and determined it, but algebraically, for one, we can't. All right, so that's how you determine if it crosses. All right, let's go to the x-intercepts and y-intercepts. X-intercept, intersect at the x-axis. So any point along the x-axis will have something in common. What they have in common is their y values. Along the whole x-axis, the y value is the same. It's y equals 0. So if we're looking for an x-intercept, I like to highlight in our notes here. We know that y will equal 0. Well, that means if y equals 0, f of x equals 0, that means the numerator must be 0 because 0 divided by any number is 0. So all we have to do to figure out our x-intercepts is set our numerator equal to 0. Now, x-intercepts are points. They're not equations of lines. Those are the asymptotes. X-intercepts, y-intercepts are points, so we need to express those as points, x, y's. Okay? So all we need to do, right, if y equals 0, that means f of x equals 0. And if f of x equals 0, that means the numerator must have been 0, right? Because 0 divided by anything is 0. So all we need to do, set our numerator equal to 0. I'm going to go back to our example that we've been working with and set this numerator equal to 0 for my x-intercepts. So I'm going to go over here, make a new little section, x-intercepts, set your numerator equal to 0, and x plus 1 equals 0, -1, -1, x equals -1, and we write it as a point. Remember y equals 0, so this is an x-intercept at -1, 0. And we saw that right here, -1, 0. Okay, so we did know that there was an x-intercept. Now look at the y-axis. Is there a y-intercept? Because that's next. Looks like there's one right there, right? So let's find what that one is algebraically. So for our y-intercepts, anything on the y-axis, those points have something in common as well. They all have the x value of 0. What color haven't I used here? Did I use this blue one? Okay. So when we're looking for our y-intercepts, it's where it crosses the y-axis and x equals 0. Again, we express this as a point, right? So when x equals 0, we're going to find y. So all we do is substitute in 0 for x into our function and solve for y. Here we go. X equals 0. Let me get my pen back out. Let's title this one y-intercepts. That means x equals 0. So let's figure out what f of 0 is. That's going to be 0 plus 1 over 1 squared minus 4. So we get 1 over -3. Did I do that right? I can't even remember. So 0 plus 1, okay. And why did I put a 1 in there? What is wrong with me? See, I make mistakes, man. I was like, something's wrong here? I just randomly put a 1 instead of 0. All right, let's try that again. 0 minus 0 squared minus 4. Okay. 1 over -4, or -1/4. So my y-intercept is at 0, -1/4. X, y. When x is 0, y is -1/4. And we can see that on our graph, right? Where is it? Right there. So that's at 0, -1/4. All right. So those are the components that we will be looking for when we're graphing rational functions. So let's try some. Maybe pause me at this point, try the next 2 examples, and then hit play and see how you did. Okay, let's see how you did. All right. So let's first find our vertical asymptote. BA, vertical asymptote. And remember to look for our vertical asymptote, we set our denominator equal to 0. Denominator equal to 0. We're looking for those undefineds or those breaks in the graph. So x plus 2 equals 0, subtract a 2, and we get a vertical asymptote at x equals -2. All right, so there's our vertical asymptote. Done. Let's go to our horizontal asymptote, HA. Now remember what we need to do for our horizontal asymptote is we have to figure out the degree of the numerator, which is n, and the degree of our denominator, which is d. So what is n? 1. N equals 1. What's d? 1. D equals 1. Remember those 3 cases. It's either n is less than d, or n equals d, or n is greater than d. Which case is this? This is case 2. So when we have n equal to d, what we do is we create an equation. Remember, horizontal asymptote to y equals equation. Y equals the leading coefficient of the numerator over the leading coefficient of the denominator. Leading coefficient of the numerator over leading coefficient of the denominator. So it's going to be 2 over 1, or y equals 2. Okay. As a refresher, if this was the case, that's a y equals 0. And if this was the case, there is no horizontal asymptote. Alrighty. Okay, let's see how you did with the x and y intercepts. Oh goodness, I keep forgetting the crossing thing. Let's do the crossing thing next. So does this horizontal asymptote cross our function? Let's figure that out. So cross, question mark. Okay, well, let's see if it crosses. We know that y equals 2, so we're going to take our equation and set it equal to our horizontal asymptote. And our equation is 2x over x plus 2. We'll set that equal to 2. And we're going to figure this out. Let's see. Put this over 1. Cross multiply. We get 2x equals 2x plus 4. Uh-oh. Look at that. We got 0 equals 4. What do you think about that? When that comes out to be not true, the answer to the question, does it cross, is no. It does not cross. Okay. All right. Let's go to the x-intercepts. I'll come back down here. X-intercepts, where it crosses the x-axis. That's when y equals 0. Remember, if this is y equals 0, then that means the numerator must be equal to 0. So all we have to do is set our numerator equal to 0. So 2x equals 0. Divide by 2, x equals 0. Now remember, an intercept is a point. Okay, so we write this as a point, 0, 0 is our x-intercept. Okay, now let's do our y-intercept. We come down here. So for our y-intercept, what do we need to do? Our y-intercept, we know x equals 0, so we replace x with 0 and we solve for y. 2 times 0 over 0 plus 2, and we get 0 over 2, which is 0. So when x is 0, y is 0, that means our y-intercept is also 0, 0. Okay. All right. We're not going to graph these. We'll graph the next two. Right now, we're just making sure we have all of this down before putting it all together and graphing. Okay. What you could do, though, what I would do is type this into your calculator and see what it looks like, and then verify your algebra with your graph. All right. Hopefully you did this one already. You're not just copying along with me. So let's go through it all over again. If you get it, fast forward me. Like, go forward. All right. Vertical asymptote. Here we go. Vertical asymptote. Vertical asymptote, we just set our denominator equal to 0, and also known as our undefined. Such a freaking function. I know I've repeated this already. Okay. And yada, 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 we get x equals 5/3. So we have a vertical asymptote at x equals 5/3. All right, let's go to the horizontal asymptote, HA. Remember for this, find n and d. What are n and d? N is the degree of the numerator. D is the degree of the denominator. We have a degree of 1 and 1. Okay, so n equals 1, d equals 1. We have the same case over here. Okay, the leading coefficient, remember, horizontal asymptote, so y equals equation, is 1 over 3. So there we have our horizontal asymptote at 1/3. Now, what we want to do, I'm not going to forget this time. We want to see if this crosses, okay? So we take our horizontal asymptote and set it equal to the equation. Okay, so does it cross? Question mark. Okay, equation equal to our horizontal asymptote. All right, x minus 4 over 3x minus 5 equals 1/3. Cross multiply, we get 3x minus 12 equals 3x minus 5. Uh-oh. You see that? 0 equals, was that I wrote as 12 there, right? A 7? Nope. So no, it doesn't cross. Okay. Alrighty, so let's go on to the last parts. X-intercepts and y-intercepts. All right, x-intercept. Okay, y equals 0. All right, that means this numerator had to be 0. So x minus 4 equals 0. X equals 4. X-intercept is a point. So this is 4, 0. All righty. And last part, y-intercept. Let's go with red here. My color choices are all over the place. Y-intercept, we know x equals 0. So we replace x with 0 and solve for y. So 0 minus 4 over 3 times 0 minus 5. That's going to be, that's a 0, Mr. She. Messy math is miserable math. -4 over -5. So that's going to be a 4/5. Okay, so when x is 0, y is 4/5, and that's my y-intercept. Alrighty, let me just make sure I did that right. All right. Okay, now for the fun. Analyze and graph the following. Okay, so calculator warmed up, ready to go. You can begin by typing that into y equals in your calculator, and let's get this party started. VA, vertical asymptote. Okay, vertical asymptote, denominator equal to 0. And this time, a little bit harder, right? We got a factor, x minus 2 x plus 1 equals 0. Okay. I don't want to take up my HA space, so set each factor equal to 0, and you get a vertical asymptote at x equals 2 and a vertical asymptote at x equals -1. Let's put those in. What do you say, Jay? So here we go. I'm going to put my vertical asymptote in at 2, right there. There we go. Stay. Okay, and I'm going to put the other one in at -1. Okay, so there they are. I like to name them, label them. This is x equals -1, and this is x equals 2. Man, I feel like this lesson is long. All right. Horizontal asymptote. So a horizontal asymptote, the trickier one. What's n? What's d? Okay, and then there's those three cases. N is degree of the numerator, 1. D is degree of the denominator, 2. Okay, remember the three cases. N less than D, N equals D, N greater than D. Okay, and this is Y equals 0. This is a little bit harder, right? You got to make that leading coefficient ratio, and then this is no horizontal asymptote. Here we do have 1 is less than 2, so we have a horizontal asymptote at Y equals 0. Okay, the way we do that is at Y equals 0, we kind of just slash it like this way at a little bit of an angle, and that's Y equals 0. Now let's go right down to, will this horizontal asymptote cross my function? My function, it's my function. Okay. So what we want to do is set our equation. Don't look over there yet, okay? Don't look at my table. Equation equal to our horizontal asymptote. Okay, so the equation here is x plus 3 over x squared minus x minus 2. And we're going to set that equal to 0 over 1. Cross multiply. Okay, we get x plus 3 equals anything times 0, 0. Subtract a 3, and we get x equals -3. So that means, yes, it will cross at -3, 0. Okay, all right, let's go ahead and do our, figure out our x-intercepts and our y-intercepts. All right, x-intercepts, go back up to this one. X-intercepts here. At our x-intercept, we know y equals 0. This is a point. These are points. Point, point. These are equations. Equations, equations. Okay. So in order for y to be 0, that means our numerator must equal 0. So just set your numerator equal to 0. X plus 3 equals 0. So x equals -3. But remember, it's a point. Y equals 0. So -3, 0. -3, 1, 2, 3, 0, we have an x-intercept. Okay, let's put that on. Let's do our y-intercepts. Y-intercepts, we know x equals 0, so we replace x with 0 and solve for y. So 0 plus 3 over 0 squared minus 0 minus 2. We get 3 over -2, which means we have a point 0, -3/2 as a y-intercept. So 0, -3/2 are right there. We have a y-intercept. Okay, now what we want to do is go to our graph, take a look at what it looks like. And also what we want to pull up is a table. So I'm going to show you the table I copied. Okay, you see where it says error, error? Why do those say error? Because those are our vertical asymptotes. Those are our undefined values. okay? So that's why they're error. They're not part of the function, okay? They're not part of the graph. So what I have here, when I look at this graph, I see that there's 3 parts to it. So I want to make sure I create a table for each part of the graph. Okay, so you want a couple points for that graph that you'll see over to the left. You'll want a couple points for that piece between the vertical asymptotes. And then you'll want a couple points to the right. All right, so copy down a table and just sketch. Okay, let me see. I think I put send back. All right, well, mine is a little off from what I had drawn on the original coordinate plane, but you kind of get the gist. So this is what yours looks like. That should be like that. Yeah, you guys get it. I'm gonna erase some of my points as they're not matching up with this picture I put. Okay, and clearly you need to make sure when you draw your vertical asymptotes, I'm using this mistake as a little mini lesson, your graph cannot cross over it. Even in a sketch, you'll lose points. It cannot cross over your vertical asymptote, okay? So I'm going to erase those, cut those out of the picture too. Okay. Oh. Can I move it all right without it? Good enough. Okay. All right. So again, get some points for over here, get some points for in between, get some points for over here, plot a few of them, and look at your graph on your calculator to just really verify the shape of them and move on. Okay, we have one more. I know it's long, but last one. All right. For those of you hanging out this long, kudos to you. All righty. Here we go. I'm going to sound like a broken record, I feel, but vertical asymptote, denominator equal to 0, factor, set each factor equal to 0. So we have x equals 0 is a vertical asymptote and x equals 3. Okay, draw those in. 0 here, 3 here, label them, name them. Okay, all right. Remember, vertical and horizontal asymptotes are equations, equations. X-intercepts and y-intercepts are points. So there's that. Horizontal asymptote, what's n, what's d? N is 2. D is 2. When n equals d, that's when we have to do a little creating of a ratio. Y equals the leading coefficient over the leading coefficient, right? So 2 over 1 or 2. So let's draw in our horizontal asymptote at y equals 2. Get this going here. 1, 2. Okay. So that's y equals 2, x equals 0, x equals 3. All right, moving on to the x-intercepts and the y-intercepts. An x-intercept, y equals 0. Just set the numerator equal to 0. Oh, this is going to be fun. I'm going to have to give myself some space here, some space and some grace here. All right, so long product sum, we have a product of -4 and a sum of 3. Well, that's pretty easy. 4 and -1. Let's expand that middle term. All right, group, GCF from each group. Sorry, y-intercept space. I'm taking it up. Well, we're going to take out a 2x. We're left with x plus 2. All right, we're going to take out a -1. We're left with x plus 2 equals 0. Take out a GCF again from each group. We're left with x plus 2 times 2x minus 1 equals 0. Whoo! Set each factor equal to 0, and we get x equals 2, and x equals 1/2. I'm still on the x-intercept. So when x equals 2 and y equals 0, there's an x-intercept there. So where shall I put my work? I'll put it right up here. 2, 0 is one of the points, one of the x-intercepts, and a 1/2 0 is another. So let's get that on our graph. 2, 0, there's one. A 1/2 0, there's the other. Okay. That's what I'm like, this doesn't match my picture. Learn from Mrs. Hershey. You gotta always look at that graph too. Okay, so you're like, yeah, that's because this is a -2. See, messy math, miserable math. See how I tried to just skip a step and I made a silly mistake, okay? All right, so we have -2, 0. That makes a lot more sense according to my calculator. Okay, there we go. All righty. So now y-intercept. I'm going to actually put this down, write this out clearly because I want to. Okay. That is all part of the x-intercept space. Y-intercept, that's when x equals 0. Stinkin' Hershey, I forgot the cross thing again. I always like to do the cross thing right after the horizontal asymptote. Oh, boy. All right, so we're going to replace x with 0. I'm going to actually come up here to do that. So 0 and then 0. So we're left with -2 in the numerator. 0 and 0. Hmm. What do you think? What in the world? What do you think about this? Well, that's not going to work. So no y-intercepts. So this function does not cross the y-axis at all. Oh, yeah, of course it doesn't, because look what's there. Look what's there, a vertical asymptote. So that makes sense. All right, let's go down to the cross part. All right, equation equal to the horizontal asymptote. All right, the horizontal asymptote was 2. And we're going to set our equation equal to that. 2x squared plus 3x minus 2 over, I believe I have to keep scrolling because that's x squared minus 3x equals 2 over 1. Okay, so cross multiply. We're going to get 2x squared minus 6x equals 2x squared plus 3x minus 2. Okay, and all we're going to do now is subtract those from both sides. All right, subtract a 3x from here and here. Get -9x equals -2. Divide by -9. Okay, so this horizontal asymptote does cross at 2/9 and 2. So that's where it crosses. Okay. 2/9 and 2. Looks about good, right? Okay. So what I did again is I went to my table of values and I copied down a table that would give me the sections of the graph, the three sections, okay? So here's section 1 over to the left, here's the middle, and here's to the right. All right, so what it looks like now is, let me see if I can go back here. All right, I'm going to move these out of the way as they're probably not lined up perfectly. I do want to point out though that I know these stop short, but this will extend, okay? So this will extend. So there's arrows here, here and here, right? They keep going, okay? So make sure you note that this extends, keeps going to infinity, okay? All right, I have to call it quits now. I'm sure you're grateful for that, but thanks for staying along for this really long ride. Appreciate it. Hope it all made sense.